I don't know. I don't know.
Yeah.
Okay, guys. I'm starting in, picking up where we left off yesterday, lesson 2.5. Okay, so we finished up example 2. And I think in your class we finished it up just about perfectly, right? And we are ready for example 3. So let's see what you remembered, what we can figure out. No. So example 3 says, write a polynomial function of minimum degree in standard form with real coefficients whose zeros include x equals 1, x equals 1 plus 2i, and x equals 1 minus I. So we are looking at standard form with real coefficients whose zeros are the given. Now, so Sadie just asked, are there going to be 6 of them? And I said no. 5.
Yeah,
5.
there's 5. I looked at the one and thought it was another one. But it's
Okay.
one.
So why are there going to be 5 zeros? Yeah, the complex conjugate zeros theorem is what it's called up the top. So anytime that there's a complex number, so it has an I involved, we're going to include its conjugate. So that means 1 plus 2i is a complex number. What is the conjugate of 1 plus 2i?
1 minus 2.
1 minus 2i. So when we set this up and we have a 1 plus 2i, we're also going to need a 1 minus I. What about 1 minus I? What is the conjugate of 1 minus I? 1 plus I. Remember to do the conjugate, you're changing the number in the middle, or the sign in the middle, right? So the sign in front of the I. And then our other one is just going to be, no, just 1. 1 is not a complex number. There's no I part. And so we will just use 1. There's no conjugate on that one. Okay, so let's set this up. F of x equals. So x equals 1 is going to be expressed how?
X negative 1.
X minus 1, because remember it's always x minus whatever the 0 is. So, next one. X minus, well, how do you guys want to do this? What do you remember?
We would like the minus outside the parentheses, sort of distributing.
Okay, so I'm going to write it up here as x minus, and then parentheses, 1 plus 2i. Now, if we think that way, then how does that become? If it's x minus 1 plus 2i, that really becomes x
1
minus 1 minus 2i. So when I write this out here, I'm going to write x minus 1 minus 2i. Well, there's always an x out in front on all of these. Like here, it's x minus the number, so x minus 1. Here, it's x minus the number, but the number is 1 plus 2i. So then that becomes x minus 1 minus 2i. So yes, there's always an x. Okay, yes. Yes. Okay. So this is x minus 1 minus 2i. What about our next one? And I'm going to put, remember, I like to put conjugates next to each other, right?
Yep.
So we just did 1 plus 2i. Now 1 minus 2i. It's going to be x what? Minus 1
Minus 1
plus 2i. Now, if you need to write it out with the parentheses first, that's fine. I'm going to write it that way every time. Yes?
You have to write the normal one after the conjugate first, right? And then you have to write the other one.
Officially, are you talking about these two here? Yes, you need to put them next to each other.
So even though there's not like, or if they get into the stuff, like the values initially in the problem, you have to do the conjugate as well in the problem.
Yes, complex conjugate theorem says you always have to do a complex number and its conjugate. Okay, now I'm ready to use 1 minus I. So remember, you're subtracting, so it's going to be x what? Minus 1 plus I, because you're changing both signs. And then to do 1 plus I, it's going to be, we're subtracting that, so what? Okay, guys, what has to happen here? A whole bunch of multiplying, distributing. Okay. What are we going to multiply here? Okay. 100% suggestion, highly recommended. Make sure you do the conjugates together first. Because when you multiply two conjugates, a whole bunch is going to cancel out. Whereas if you multiply two just random picks, you're not going to have all the canceling. You can get to the same answer, but man, it's going to be a lot more difficult, is my opinion. Okay, so in this case, that means the x minus 1 is just going to carry down right now. It's on its own. It's just going to carry down. We'll come back and worry about it later. Okay, so let's multiply the first two conjugates and then the second two conjugates. Now, keep in mind, when you multiply a 3 by 3, so trinomial times trinomial, we're actually going to end up with 9 terms before we do our simplifying. But it'll simplify down to 3 terms in this this case. Okay, I'm going to be consistent. Try and be consistent here. I'm going to take the x in the first parenthesis and distribute it to all 3 terms in the next parenthesis. So x times x, x squared. X times minus 1, minus x. X times 2i, plus 2ix. Now I'm going to distribute the negative 1. Negative 1 times x, minus x. Negative 1 times negative 1, plus 1. Negative 1 times 2i, minus 2i. And then distribute the negative 2i. Negative 2i times x, minus 2ix. Negative 2i times negative 1, plus 2i. And then negative 2i times positive 2i, minus 4i squared. Did I do that right? I had a brief moment where I lost track of where I was at.
Yeah, you got it right.
Okay.
I think maybe I'm reading it wrong.
No, I think you're right. Did I? Well, no.
No,
I looked at the wrong term.
Oh, yeah, I was too. I'm all confused. Okay.
It's okay.
Don't let your brain sidetrack for even a brief moment, because that's what, I don't know what my brain did, but it took a brief departure for a moment, and I came back, and what was I doing?
It took a brief bathroom break.
Okay, now we've got 2 more, yes?
yes.
Okay, I'm going to try and do the same thing and not lose my place this time. So I'm going to take x from the first parenthesis, times distribute to everything in the last parenthesis. X times x, x squared. X times negative 1, minus x. X times negative I, minus ix. Now I'm going to distribute the negative 1. Negative 1 times x, minus x. Negative 1 times negative 1, plus 1. Negative 1 times negative I, plus I. And lastly, I have an I to distribute. I times x, plus ix. I times negative 1, minus I. I times negative I, minus I squared. Okay. The x minus 1 is still going to carry down. What do I need to do in these other two parentheses?
Like terms.
Some serious cleanup, right? Okay, as we look at this middle one, 2ix minus 2ix cancels. Negative 2i plus 2i cancels. And what do you know about negative 4i squared? It's negative 4 times negative 1, which becomes plus 4, correct? So, clean this up. X squared carries down. Negative x minus x, negative 2x, and 1 plus 4 plus 5. Notice all my I terms cancel out and my I squareds I changed. Check the next one. What cancels? Minus ix plus ix cancels. Plus I minus I cancels. And what do you know about minus I squared? Yeah, it's minus negative 1. And minus negative 1 is plus 1. So clean this up. You'll notice it's going to clean up just like the last one did. Keep the x squared, minus x, negative 2x, and 1 plus 1 plus 2.
Man, where is this?
I'm running out of time.
You got that.
I had to do more steps than that because I didn't remember them all across.
That's where a small handwriting.
Okay. What do I need to do now?
Do it again.
Multiply again, right? We've got 3 sets of parentheses. It's pick 2. I personally, when I do this one, I'm leaving the x minus 1 where it is, and I'm doing the 2 big ones, and then I'll deal with the x minus 1 at the end. I'm not saying you have to do that, though. Okay? So I'm going to carry down my x minus 1. Notice I keep carrying it down. I don't want to lose it. Okay, I'm going to distribute the x squared from the first parenthesis to everything in the second parenthesis. X squared times x squared is x to the 4th. X squared times minus 2x, minus 2x cubed. X squared times 2, plus 2x squared. Now I'm distributing the negative 2x. Negative 2x times x squared, minus 2x cubed. Negative 2x times negative 2x, plus 4x squared. Negative 2x times 2, minus 4x. And now I'm distributing the 5. 5 times x squared, plus 5x squared. 5 times minus 2x, minus 10x, and 5 times 2, plus 10.
Oh, goodness. There's so many down on those.
Okay, carry down the x minus 1. Are you cleaning it up?
Yes.
These 4 things cancel.
I already got it cleaned up.
X to the 4th carries down. Negative 2x cubed and negative 2x cubed becomes negative 4x cubed. 2x squared plus 4x squared plus 5x squared,
11x squared.
11x squared. Negative 4x minus 10x, negative 14x, plus 10.
Wow.
Okay,
If you just look at this, you'd probably just give up.
now what?
Now you're
so
going to do
close.
it again.
We're so close.
Okay, now, this is the easy part. I mean, as this problem goes, it's a difficult problem, but this is the easy part. Although we're honestly just doing a lot of algebra 1. It's just big bad algebra 1.
I'm below the block line right now.
Okay. That's all right. I will be too for my final answer. Just not already there. We'll keep it. Okay, Sadie, ration this out. We have to multiply and then simplify. That's what you need lines for. Did you move over left and use your space left maybe so you don't have to... Well, I'm saying like scoot over to the left edge of the... Then maybe you won't.
Yeah.
Too late now. Okay. Okay, I'm going to take the x and distribute it to everything, which that's easy, right? That just means all my powers go up 1. So it becomes x to the 5th minus 4x to the 4th plus 11x to the 3rd minus 14x squared plus 10x. And now I'm going to distribute -1. That just means I'm going to change my signs. Minus x to the 4th plus 4x cubed minus 11x squared plus 14x minus 10. Final answer. X to the 5th. Minus 4x to the 4th minus x to the 4th. Minus 5x to the 4th. 11x cubed plus 4x cubed. Plus 15x cubed. Minus 14x squared minus 11x squared. Minus 25x squared. Plus 10x plus 14x. Plus 24x minus 10.
Oh, goodness. I haven't said another parenthesis. I'm done with this.
And good news is, it matches the answer in my answer key.
Oh my goodness.
If it didn't, I probably just don't know how to do that.
Well, I just did this problem this morning in second period, so you know I'm familiar with it, and, you know, like it's fresh in my head. Okay, guys. They're going to take practice. They're going to take just a little bit of time. But it is important that you practice now so that when it comes to test time, you know what you're doing. You're not making, get the careless mistakes out of the way now. If you're multiplying that stuff and in the habit, you'll be less likely to make careless mistakes later. Okay. No one online, no one virtual complained that I was in the glare, so hopefully you guys were just listening. I know.
Maybe they have so much like
No, there's not.
see that.
Oh, it's... Yeah, okay. Like I say, there is some, but just depends on what view you have. I say everything out loud that I write, so. Okay. You ready for the backside? It's therapeutic as long as you have the teacher catching all your mistakes as you go, right? Okay, on the backside. Look at this problem. Find all zeros of this function and write its linear factorization. Find all zeros. Have we done something like that?
Yes, y'all are.
We're going backwards now.
Okay. The difference when we had to find the zeros, we were finding all real zeros. Now we're just finding all zeros. However, it doesn't change the process. Okay? So this is the same thing you did on the quiz. Maybe try the calculator. Depends on the situation. Okay? Yes, this one we will have to look at the calculator. Technically, before we do the calculator step, think about PRRs, right? So you can... Okay, so PRRs finds potential rational roots. So obviously we're not going to find the complex imaginary ones. And we're still not finding irrationals, but it gives us our starting point. Now, which by the way, when I get done with this problem, it says find all zeros. How many zeros am I going to have?
At least five.
How about exactly 5? How do I know there's exactly 5?
One,
imaginary.
2,
What's my highest power?
5.
5. That says there will be 5 total zeros. Now, some of those may be imaginary, but there's 5 zeros. So if we look at PRRs, it's factors of 8, which are 1, 2, 4, and 8, plus or minus all those, over factors of 1. Okay. Definitely put it in your calculator and tell me what the graph suggests.
Okay, you're a little bit ahead.
could have won.
She was graphing while we were all chatting. Okay, so you get it in the graph. It appears as -2, 1, and 4. Which, by the way, this is the one that made me ask this morning. Did you guys all see the email about graphing calculators? I know.
I didn't see that.
And it's probably irrelevant for most of you because no one probably needs to go buy a new calculator necessarily. However, that 50% off coupon is on these. And so if you are in the market for upgrading, that's the best deal I've ever seen.
I need to upgrade.
Well, it all kind of depends. If you already paid money for a calculator this year, do you want to pay money for another calculator?
I mean,
No.
mine. What if it breaks?
Well, okay. But my point is, if you have a loan, someone loaned you one or something, now you think, oh, that sounds like a good deal or something. Okay, that's, it's a personal choice there. I didn't send it out with the idea of, oh, hey, you can go buy a new calculator now. It's, if you didn't get one at the beginning for some reason, you're just borrowing or something, And Hans, I'm not referring to you. I don't expect you to go buy one, okay? No, you're fine. I'm not referring to you. Okay? I'm talking about other people that, they want their own and, I'm not referring to you. Some of these guys will continue with me into calculus next year and they'll have to have it also. So,
You're stuck with me for another year, Mrs. Sargent.
no sleeping.
I'm not going to.
Okay. Back on track. Okay, the graph suggested -2, 1, and 4. So, what do I do with those numbers?
You do the little thing thing.
Synthetic.
Okay, synthetic division. Okay. Make sure you know how to do synthetic division, folks. A few people struggled in various points on the quiz, which told me you hadn't really paid attention and gotten it figured out. In my box here is -2. Next to the -2, 1, -3, -5, 5, -6, and 8. Drop the 1. -2 times 1, -2. -3 plus -2, -5. -2 times -5, 10. -5 plus 10, 5. -2 times 5, -10. 5 plus -10, -5. -2 times -5, 10. -6 plus 10, 4. -2 times 4, -8. And 8 plus -8, 0. Inner cheer, right? Yes, I got it. No mistakes. Okay, now what? Now we're going to try another one.
You carry it over.
You must carry it over.
Let's carry it over.
It is impossible to finish this problem if you always go back and use the original row. You need to use your new row, or you will not be able to finish this problem. So, instead of using my original problem, I'm going to use my last answer. So, 1, -5, 5, -5, 4. Again, drop the 1. 1 times 1, 1. -5 plus 1, -4. 1 times -4, -4. 5 plus negative 4. 1. 1 times 1. 1. Negative 5 plus 1. Negative 4. 1 times negative 4. Negative 4. And 4 plus negative 4? 0. Woohoo! Okay. And now, we're going to try, what have I not tried yet? 4. Again, don't go back to the original. Use your new row. And so my new row, 1, negative 4, 1, negative 4. Drop the 1. 4 times 1. 4. Negative 4 plus 4. 0. 4 times 0. 0. 1 plus 0. 1. 4 times 1. 4. Negative 4 plus 4. 0. Okay, guys. Now, what are the directions on this problem? All zeros and linear factorization. So, before we find our last 2 zeros, I'm going to start writing my linear factorization out. In that, f of x equals, so the first zero we knew for sure was negative 2. How do I write negative 2 as a factor? It's x minus negative 2, which is x plus 2. Then the next one we found that worked was 1. What's 1 as a factor? X minus 1. And then we found 4 worked. And 4 as a factor is x minus 4. Now, according to this problem, we need 5.
Imaginary.
What does this 1, 0, 1 represent?
X squared plus 1
Yeah.
0.
So, if you recall, over here it was x to the 5th. So then this one was x to the 4th, which makes this one x to the 3rd, which makes this 1x squared plus 0x plus 1. Or, better written, is x squared plus 1. Take that and set it equal to 0. How do you solve if it's x squared plus 1 equals 0?
Subtract 1 over.
Subtract 1.
Square root it.
X squared equals negative 1. And square root it. What is the square root of negative 1? I.
Which equals.
And plus or minus I. I and negative I. Because anytime you take the square root in an equation setting, plus or minus. So now, finish our linear factorization. If my next zero is I, how do I express I in a factor? X minus I. And then how do you do a negative I? It's x minus negative I, which becomes x plus I. And that is a valid point there. These i's always appear in pairs. Okay, they're the conjugates, right? Well, notice, I is a square root, and so square roots are plus or minus. Okay, you got it? Okay, that's the basics there. We're going to go ahead and start the next problem. I am well aware that we won't get the next problem done, most likely. However, hear me now. Homework is still due tomorrow. Okay? What I'm going to ask you to do, and I will finish this problem regardless tomorrow. And it also means that a couple of problems at the end of your homework may be a little more challenging. Okay? You may not quite be ready for them. But I still want you to go ahead and do the homework because I don't want to spend yet a whole other day. Okay? So we'll spend time tomorrow finishing this problem, looking at homework and that kind of thing. Okay? So I'm going to ask you to do everything you can in homework tonight. Okay, let's look at how example 6 is a little different. The complex number z equals 1 minus 2i is a 0 of this function. Find the remaining zeros and write its linear factorization. Okay, how many total zeros am I going to have in the end? 4, because my highest power is 4. Okay, just an FYI there. Now, what do you notice on this one? They gave us 1 minus 2i as a 0. So nice of them. Well, considering if you graph this, you're not going to find any on the graph. It's very nice of them.
Wow.
Because this problem would be rather difficult if they didn't give us a starting point. Okay, I don't really know. I don't know if it would be possible. Okay, so they gave us a starting point. Now, what do you know about 1 minus I? Or, sorry, 1 minus 2i. Did I say 1 minus I instead? Okay. What do you know about 1 minus 2i? We also have to include the conjugate 1 plus 2i. So they didn't really just give us 1 0, they gave us 2 zeros. Okay, so you don't need to really do PRRs because you're not going to find any. Well, you'll find PRRs, but when you look at the graph, you will find no x-intercepts. That's the way it is. So, what do we do once we have a value? No.
We have to do that if no.
Lord.
Synthetic division.
Yes, I love it.
Here we go. Now, the 0 they gave me
Not a good one.
is 1 minus 2i. So in my box is going 1 minus, okay guys, you gotta quit giving me these looks here. I can't focus. I can't focus when there's something on my screen either, but, okay. So the 0 I'm being given is 1 minus 2i. Now, as I set this up, kind of spread your numbers out a little bit more, okay? Just giving you advice here. 4. Oh, crud. Well, it doesn't affect you because I just caught my mistake for you guys. I made a mistake in my morning notes. Crud. Okay, what comes after the 4?
No,
Nope.
It's a 0 because there's no.
Oh, yeah. You have to do 0.
A 0.
Oh, you didn't do that.
I did. I was in a hurry and I didn't even glance at these notes. And okay, so don't forget to put placeholder zeros. I haven't been reminding you as much lately, and thus I'm failing myself. So, a 4 for x to the 4th, a 0x cubed, a 17x squared. Again, you should be spreading these out some. A 14x to the 1st, and then a 65.
We can do that. Miss Sargent, you are not failing yourself because you gave me a B+ last quiz, so you're doing pretty good.
I don't give grades. I don't give grades.
You talk about stuff, so you're doing pretty good.
Okay. Same rules. You drop the 4, yes? 1 minus 2i times 4. 4 minus 8i. You distribute. Easy enough, right? 0 plus 4 minus 8i. 4 minus 8i. Now what? Unfortunately, no.
4 plus 8i.
16i.
We have to multiply 1 minus 2i times 4 minus 8i. Which, how do I multiply those? We FOIL. Notice, I'm bringing it down to the bottom there just so I can have a little room to show some work. Actually, you guys know what? I did get the 0 in there this morning. Okay. Oh man, they would be so mad at me. I just don't think we talked about it. I think I just randomly wrote it real quick. Okay. So, we're going to FOIL. 1 times 4 4. 1 minus 8i minus 8i. Negative 2i times 4. Negative 8i. Negative 2i times negative 8i.
Plus 16i squared.
Plus 16i squared. Okay. Now we have to clean this up. 4 can add to 16i squared. What is 16i squared? Negative 16. So 4 minus 16 is negative 12. Negative 8i minus 8i. Minus 16i. So what am I going to put up above? Negative 12 minus 16i goes under the 17.
I don't know where that one adds.
So negative 12 minus 6i has to add to 17. 17 is a constant, so it adds to the 12. 17 plus negative 12 is 5 minus 16i. And now we're going to FOIL again. This time I'm FOILing 1 minus 2i times 5 minus 16i. 1 times 5, 5. 1 times minus 16i, minus 16i. Negative 2i times 5, minus 10i. Negative 2i times negative 16i, plus 32i squared. 5 plus 32i squared is 5 minus 32, negative 27. Negative 16i minus 10i, minus 26i. Of course. So now I have negative 27 minus 26i. And we're adding that to 14. 14 plus negative 27 is negative 13 minus 26i. And now we have to FOIL one last time. 1 minus 2i times negative 13 minus 26i. 1 times negative 13, negative 13, minus 26i, plus 26i, plus 52i squared. What do you notice about the middle terms this time? They finally cancel. Negative 13 plus 52i squared, which is negative 13 minus 52. Negative 13 minus 52, negative 65. And 65 plus negative 65 is 0.
I guess I should have known because they gave it to us.
They gave it to us as a 0, so it has to work. Now, why'd we have to do that? Because tomorrow when we pick up on this problem, we're going to use this one and do 1 plus 2i. Now, here's the good news. You won't have all this extra crazy FOILing. It will work a lot nicer on the next one. It'll be more just distributing. Do the homework to the best of your knowledge. I think the last couple of problems are the ones you're going to get stuck on, but you can still start them. It's page 215, 2 through 36, evens. You should not get a remainder, because if you get a remainder, it doesn't work. So if you get a remainder, something went wrong. And if anyone's still virtual, it wasn't wrong in Skyward this morning, I was told, but it is supposed to be 2 through 36 evens, not 26, as Skyward mistakenly said this morning.